Before we talk about what Open RAN is, I thought it worth touching on why. Why it is even a thing. It's all about cost. The cost of building a mobile network is huge. That won't be a surprise to any of you. The lion's share of that cost is in the radio network, i.e. the cell towers, the radio transceivers at the top of the tower, the baseband unit often at the bottom or near the tower, and all the switches and processing that brings data back to the core. As much as 70% of the total cost is in the radio portion of the network. Traditionally, if a mobile operator was planning to build a network, they would have to use a single vendor's equipment for most of the radio network because they are all using proprietary protocols. So the supply chain was something of a closed shop, a small number of vendors supplying all equipment, no specialization, little competition, and a virtual monopoly once a vendor has been selected. For 5G, those costs are likely to be even higher. The reach of new radio technology is often more limited than 3G or 4G, so the cells will be closer together and therefore more are required to cover the same area. The higher throughput will require greater processing power and faster silicon. So in an attempt to get costs under control, the great and the good in the industry conceived the idea of breaking the network into component pieces and defining standard interfaces between those individual pieces of equipment in order to allow new and specialist equipment manufacturers to enter the market and to enable them to mix and match items. Open RAN isn't an alternative to 5G. It's an alternative way to build a 5G network. It's important that you notice the segue on this slide from Open RAN to ORAN with a hyphen. Open RAN is a concept or school of thought. There are many groups thinking those thoughts and talking about the concept but little concrete definition. So you'll see the term Open RAN and ORAN without a hyphen used interchangeably. ORAN with a hyphen, on the other hand, is an alliance of operators and vendors that have gotten together and laid down a framework and standards for how this should all work. It is the standards that have been defined by the ORAN Alliance that we'll be working with from here on, and so everything will be ORAN with a hyphen. The ORAN Alliance has defined three primary components of the radio access network. The ORU, or radio unit. This is essentially the modulator and radio frequency transmitter. These are by nature geographically distributed so they can achieve coverage. The ODU, or distributed unit, performs much of the processing of user data in preparation for radio transmission, as well as control of the radio units. The user data is referred to as U-plane data, and the control as C-plane. The DU also allows general management of RUs by what is referred to as M-plane data, that generally comes from the core and via the CU. The CU then provides the higher level processing and connection back into the core. An important thing to note here is that the DU is often connected to the RU by a packet network, the front haul network, and not with a traditional point-to-point fiber connection. That network can and generally will have some latency and timing variability. That network needs to be very carefully designed and tested to provide deterministic data transfer, as opposed to traditional best effort packet networks where some packets take much more time to be delivered, can arrive out of order, or may be lost. The 5G network would cease to function if that were the case. Along with these three primary components will be a selection of routers and switches as required to construct the network between devices. We have already touched on the types of data carried over the front haul network, or planes as they are called. In addition to those already mentioned, and critical to the functioning of the network, is the synchronization plane. The S-plane is the protocol that keeps the internal clocks on the ODU and ORU and devices in between locked to a reference source so that they can communicate successfully with each other. Without it, the RF transmissions would interfere with each other. User equipment, your cell phone, wouldn't hand over from one tower to the next and communications would collapse. In summary then, an ORAN network is a novel way to build the front end of a 5G network and achieve the end application requirements as defined by the 3GPP. The synchronization plane is critical to the operation of the network. Designing and testing the network synchronization plane is complex and challenging. The network architects will demand devices that conform to essential requirements. Join us in the next video where we will outline the requirements, challenges, and methods for testing the synchronization performance of devices and networks.